Good evening, students. We have to study a D flip-flop. The D flip-flop is a modification of the clocked SR flip-flop as shown in figure. Okay. There is a one difference between the SR flip-flop and D flip-flop is that here we are inverted. We are using as a NAND gate as a not gate for inverting. Okay. And there is a clock pulse also, and it's the half of this is similar to the SR flip-flop. Now this is a logic diagram and a graphical symbol. D, clock pulse, Q and Q bar. These are the output states. Now we will design the characteristics table QT D 00, 01, 10, 11. Okay. Now, as shown is there, if we are giving a 0, okay, if we are giving a 0, so there will be we will name that these NAND gates first, second, third, fourth. So, this 0 is going as an input to this NAND gate, and we are giving a clock pulse as a 1. If we are giving a clock pulse 0, it will not trigger out. Okay, means it will not work out. 0 and 1, we will get a 1 output, and 0 will inverted give you a 1. 1 will give you a 0. Now 1 directly, this 0 will get a direct output. We know that here's a 1, so we need a feedback. This 0 will give a output as a 1. Okay. Now 1 will be a feedback to the 3 NAND gate number 3. 1 and 1 gives you a 0. So what we get a characteristics table? When the D flip-flop is 0, so we get a output is 0. Means our next state is our 0. Okay. And QT bar is here we can also write that the QT bar will be the same as the not the same, it will get inverted of a QT, because here the QT is 0, so QT bar will be 1. It's also shown here. If we get a 0 output in QT, so 1 in Q bar T we get output 1. Okay. If we are giving a output input now 1. Okay, 1. If we are giving an input 1, so 1 will give you a 0, and this 1 will get not, means 0. Now 0 and 1. Okay. Now 0, this is a 1. So we get a direct output. Now this 1 will feed back to the fourth NAND gate. 1 and 1 gives you a 0. Means our output is when we are giving a D 1. So we getting a QT is 1. So it is similar to the when we are giving a D 0. So we get a next state is 0. So it will be similar to this also. Okay. And when we are giving a 1 input as in D flip-flop, so it will similar to the above of this. Okay. So what a D flip-flop is, where we can use this D flip-flop. The D flip-flop can be used as for delaying the circuit. Okay. It can used in a registers, ring counter. Okay. In our next unit we will study about that registers and ring counter. So basically delay flip-flop is used for the delaying the circuit. Okay. Now it's over. Next we will study about JK flip-flop. Okay.